Welcome to Astronomy Daily, your go-to source for the latest developments in space and astronomy. I'm Anna, and in today's episode, we'll explore fascinating discoveries about lunar volcanism, solar system formation, China's space endeavors, and more. Today, we've got an exciting lineup of stories that reveal new insights into our cosmic neighborhood. From groundbreaking analysis of moon samples to fresh understanding of our sun's birth, plus the latest developments in space exploration and astronomical research. Let's dive into these remarkable discoveries that are reshaping our understanding of the universe. In a groundbreaking discovery, China's Chang'e 6 mission has revealed fascinating new details about the moon's volcanic past. The mission made history this June by becoming the first to retrieve surface samples from the far side of the moon, the hemisphere that perpetually faces away from Earth. Analysis of these precious lunar samples has uncovered volcanic rock fragments dating back an astounding 4.2 billion years, with additional samples from 2.8 billion years ago. This evidence points to an incredibly long period of volcanic activity on the lunar far side, lasting at least 1.4 billion years during the moon's early history. The samples were collected from the South Pole Aitken Basin, an impact crater with the thinnest lunar crust, making it an ideal location for studying ancient volcanic activity. Using advanced radioisotope dating techniques, scientists found that these volcanic rocks originated from different sources of magma in the moon's mantle, indicating a complex and dynamic volcanic history. What's particularly interesting is how these findings differ from samples previously collected from the moon's near side during earlier missions. The Chang'e 6 samples show distinct compositional differences, suggesting that volcanic activity varied significantly across the lunar surface. This extensive period of volcanism eventually came to an end as the moon's internal heat sources diminished. Being smaller than Earth, the moon cooled more rapidly, and its volcanic activity gradually ceased as its mantle temperature dropped below the threshold needed to sustain these dramatic geological processes. These findings not only provide unprecedented insights into the moon's geological evolution, but also help us better understand how our celestial neighbor transformed from a dynamically active world into the quiet, crater-marked satellite we see today. Scientists have made a remarkable breakthrough in understanding the origins of our solar system, pinpointing for the first time how long it took our sun to form. Through sophisticated analysis of ancient stardust and groundbreaking laboratory experiments, researchers have determined that our star took between 10 and 20 million years to come together from a molecular cloud of gas and dust. The discovery was made possible through an innovative experiment at Germany's GSI Helmholtz Center, where scientists successfully observed the rare decay of highly charged thallium into lead. This observation provided crucial data about radioactive isotopes in stars of different masses and ages, allowing researchers to build a more complete picture of stellar formation. Red giant stars play a particularly important role in this cosmic story. These aging stars are the only places in the universe where certain unstable isotopes of lead are generated. These isotopes then mix into giant clouds of gas and dust, where they begin to decay. Our sun formed from such a cloud, and some of the earliest solid fragments trapped this lead, effectively creating a timestamp that researchers could use to determine the formation period. What makes this discovery particularly significant is that it's the first time scientists have been able to provide a concrete estimate for how long this process took. The research could have far-reaching implications for our understanding of how other solar systems develop and how planets form around their parent stars. This timeline of 10 to 20 million years might seem incredibly long by human standards, but in cosmic terms, it represents a relatively brief period in the 4.6 billion year history of our solar system. The findings provide a crucial piece of the puzzle in understanding how our cosmic neighborhood came to be. China's space program has marked another significant milestone with the successful launch and docking of their Tiangong-8 cargo spacecraft at the Tiangong-space-station. The spacecraft lifted off from the Wenchang spaceport aboard a long March 7th rocket and completed its journey to the station in just over 3 hours. This mission carried approximately 6,000 kilograms of vital supplies, most of which will support both the current Shenzhou 19 crew and the upcoming Shenzhou 20 mission. But what makes this delivery particularly fascinating is the inclusion of 458 kilograms of scientific materials, including some groundbreaking experiments that could shape the future of lunar exploration. One of the most intriguing experiments aboard Tiangong-8 involves a set of experimental bricks manufactured from simulated lunar soil. These bricks will be exposed to the harsh environment of space for about 3 years, subjected to intense radiation, extreme temperature fluctuations, and the vacuum of space. After their prolonged exposure, they'll be returned to Earth for detailed analysis, providing crucial data for China's ambitious plans to construct habitats on the Moon as part of their International Lunar Research Station project planned for the 2030s. The Tiangong-8 spacecraft itself represents an advancement in cargo delivery capabilities, featuring an additional 102 kilograms of payload capacity compared to its predecessors. This improvement in cargo capacity demonstrates China's growing expertise in space logistics and their commitment to maintaining a permanent presence in orbit. This mission forms part of China's broader vision for the Tiangong-space-station, which they plan to operate for at least a decade. Their ambitious plans include expanding the current 3-module configuration to 6 modules and adding a co-orbital space telescope called Suntian in the coming years. These developments highlight China's increasing capabilities in space exploration and their determination to establish a significant presence beyond Earth's atmosphere. There's been a lot of interest in UFOs this week, and there's more to report. The Department of Defense has just released its annual report on unidentified anomalous phenomena, or UAP, revealing some fascinating findings from their ongoing investigations. The report covers sightings and incidents from May 2023 through June 2024, building on previous data to create a comprehensive analysis of over 1,600 cases. One of the most notable aspects of the report is that the All-Domain Anomaly Resolution Office, or AARO, has found no evidence linking these phenomena to foreign adversaries. However, they acknowledge that their ability to resolve cases continues to be limited by the lack of timely and actionable sensor data. To address this challenge, AARO has begun implementing new detection capabilities, including a prototype sensor system called Gremlin. This system, designed specifically for detecting, tracking, and characterizing UAP, has already demonstrated its functionality during a test event in March 2024. The next phase involves a 90-day pattern of life collection at a site of national security interest. The office is taking a rigorous scientific approach to these investigations, emphasizing the importance of documenting and analyzing each report through a data-driven framework. They're also expanding their collaborative efforts, working with military and technical partners to optimize sensor requirements and improve information sharing processes. Looking beyond domestic borders, AARO is actively engaging with international partners to share information and develop best practices for resolving UAP cases. They're also fostering partnerships across government agencies, academia, and commercial communities to enhance their technological capabilities and analytical tools. This systematic approach to investigating UAP represents a significant shift in how these phenomena are being studied, moving from speculation to scientific methodology. The emphasis on data collection and analysis suggests a serious commitment to understanding these unexplained occurrences while maintaining a focus on national security and air safety. While on the subject of UFOs and alien life, here's a story that won't go away. A fascinating new perspective on NASA's historic Viking Mars missions has emerged, suggesting we might need to fundamentally rethink our approach to searching for life on the red planet. According to astrobiologist Dirk Schulze-Makuch from the Technische Universität Berlin, the Viking landers may have actually discovered Martian life back in 1975, but ironically might have accidentally killed it in the process of looking for it. The Viking missions, which marked humanity's first successful landing on Mars, conducted experiments designed to detect microbial life by adding water and nutrients to Martian soil samples. While these tests initially showed some positive signals for biological activity, most scientists ultimately concluded the results were either negative or inconclusive. However, Schulze-Makuch's research, drawing from studies in Earth's Atacama Desert, suggests that any life adapted to Mars's extremely arid conditions would be highly sensitive to liquid water. Just as desert microbes on Earth have evolved to survive with minimal moisture, Martian organisms would likely be adapted to their planet's ultra-dry environment. In fact, when the Atacama Desert experienced unusual heavy rainfall, scientists observed that up to 80% of its indigenous bacteria died from the sudden water exposure. This insight raises an intriguing possibility. The Viking experiment's water-based approach might have been too much of a good thing. Rather than following the traditional follow-the-water strategy, Schulze-McCutch suggests future Mars missions should consider a follow-the-salts approach. This is because certain salts can help organisms extract tiny amounts of water directly from the atmosphere, a survival strategy that would be crucial in Mars's harsh environment. Looking ahead, this research emphasizes the importance of developing more nuanced approaches to detecting extraterrestrial life, ones that take into account the specific environmental conditions of other worlds rather than relying solely on Earth-based assumptions. Time for one last story today. A fascinating new study has revealed significant flaws in our understanding of massive stars and their explosive deaths as supernovae. Using an innovative experimental approach, scientists at Michigan State University's Facility for Rare Isotope Beams have uncovered evidence that challenges our current models of stellar evolution. The research focused on iron-60, a rare and unstable isotope that forms inside massive stars and gets scattered across the galaxy during supernova explosions. What makes this isotope particularly interesting is its remarkably long half-life of over 2 million years, allowing it to serve as a lasting signature of ancient stellar explosions. The team developed a groundbreaking method called the Beta-Oslo method to study these unstable isotopes, overcoming the significant challenges of working with such short-lived materials. Their findings suggest that the production of iron-60 inside massive stars occurs at nearly twice the rate predicted by current theoretical models. This discovery points to fundamental flaws in our understanding of how massive stars operate and eventually die. The researchers suggest that existing models may need significant revisions, particularly in areas such as stellar rotation rates and the conditions required for stars to go supernova. These findings don't just represent an isolated discrepancy. They potentially impact our broader understanding of stellar evolution, element formation, and the chemical enrichment of galaxies. The team's work suggests that the internal workings of massive stars may be quite different from what we've long assumed. This research marks another reminder of how much we still have to learn about the universe's most powerful stellar engines. As we continue to refine our understanding of massive stars and their explosive deaths, we may need to revise many of our assumptions about stellar evolution and the processes that create the heavy elements essential for life in the universe. And that's it for today's edition of Astronomy Daily. If you're looking for even more space news, try visiting our website at astronomydaily.io. There you can find our continuously updating newsfeed, listen to all our back catalog, sign up for our daily newsletter, check out the deals from our sponsors, or send us a message. You can also keep up to date by following us on our social media channels. Just look for Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. Until next time, keep looking up and wondering about the mysteries of our cosmic neighborhood. This has been Anna with Astronomy Daily.